Hello and welcome to Code Skwela. We are now in our fourth hour or hour number four of our CS50 Computer Science course. And now, we have already gone through 3 hours of uh, these lectures. And and so just a quick recap if I can uh, review what I have written down on my uh, notes here. So uh, just a quick recap. So from the previous hour or hour number three of the lecture, uh, several things has been discussed. So yeah, we have terminal commands so that when you work with coding uh, C, you mostly work with terminal commands or with the CLI. Okay, so several commands has been discussed. Along with that, he has also mentioned or tackled the uh, programs as functions. Okay, we have uh, part of a function is arguments and then its return value, and then several different operators has been discussed. Programs have or variables also have data types, and part of an IDE or the program
On
that
that, but it's
you're
really just a
so
precursor.
sorry, the program that you're using to write your code includes syntax highlighting. And and there's also another thing that has been mentioned is when you're coding in C, you can use header files or libraries, or these are external programs that is made available to you. uh, yeah and so operators, syntactic sugars, and that was most of the content for the previous hour. And so now we will continue another hour of this lecture. And so I hope you are ready and prepared for this one, because we have barely uh, scratched the surface of this entire course, which would take 20, like I guess almost 25 hours of lectures. So uh, let of course I have my trusty pen and my paper to take notes in case we have something to discuss about. And let's not make this any more longer. And so join me. And before I forget, please like and subscribe to our channel so that you get updated to any future videos and lessons and tutorials in the channel. And so uh, let's start.
Cursor for all the problems that we're going to have to eventually deal with later on. Good question. Yes, if we were still using Z, we would also have to change it to a long. Otherwise, we'd be ignoring 32 of the bits that had been added together via the longs. Good question. All right, so how about we spice things up with maybe not just addition here? How about something with some conditions? Let's start to ask some actual questions. So a moment ago, recall that we had just the declaration of variables. Now let's look back at something in Scratch that looked a little something like this. A bunch of puzzle pieces asking questions by way of these conditionals, and then these Boolean expressions here in green, maybe saying something like x is less than y. In C, this actually maps pretty cleanly. It's much cleaner from left to right than it was with printf and join. Here we have just code that looks like this. If a space, two parentheses, and then x less than y, and then we have something like printf there in the middle. So here, it's actually kind of a nice mapping. Notice that just as the yellow puzzle piece in Scratch is kind of hugging the purple puzzle piece, that's effectively the role that these curly braces are playing. They're sort of encapsulating all of the code on the inside. The parentheses represent the Boolean expression that needs to be asked and answered to decide whether or not to do this thing. And here's an exception to what I alluded to earlier. Usually, when you see a word and then a parenthesis, something, and then close parenthesis, I claim that's usually a function. And I still feel pretty good about that claim. But there are exceptions. And the word if is not a function. It's just a programming construct. It's a feature of the C language
It's a
that
keyword.
similarly uses parentheses just for different purposes, for a Boolean expression. How about something like this? Last week, if you wanted to have a two-way fork in the road, go this way or that way, you can have if and else.
If
In
else.
C, that would look a little something like this. And if we add in the printfs, it now looks quite like the same, but it adds, of course, the word else and then a couple of more curly braces. As an aside, in C, it's not strictly necessary to have curly braces if you have only one line of code indented underneath.
Right. Yeah.
For best practice, though, do so anyway, because it makes super clear to you and ultimately anyone else reading your code that you intend for just that one or more line of code to
So if you are, or if you have been familiar with C sharp, yeah, it follows the same syntax. Okay.
execute. How about this from last week? Here was a three-way fork in the road if x is less than y, else if x is greater than or equal to
So
greater
you
than
have
y,
nested
else
ifs.
if x equals
Yeah.
y. Now here's where you have
Nested
some
ifs.
disparities between Scratch and C. Scratch uses an equal sign for equality, to compare two values. C uses a single equal sign for assignment, from right to left, minor difference between the two worlds. In C, we could implement the same code like this, the addition being just this additional else if, and if we add in the printfs, it looks a little something now like this. This is correct, both in the Scratch world and in the C world, but could someone make a claim that this is not, again, well designed? Exactly. We don't need the last if. We need the else, at least, but we don't need the last if because, at least in the world of comparing integers, it's either going to be less than, greater than, or equal to. There is no other case, so you can save a few seconds, if you will, of your program running, a blink of the eye, by only asking two questions and then inferring what the answer to the third must be just by nature of your own human logic here. Now, why is that a good thing? If, for instance, x and y happen to equal each other, I type in 1 and 1 for both values, either in Scratch or in the C world. In the case of this version, you're sort of stupidly asking three questions, all of which are going to get asked, even though the answer is no, no, yes. That is true, false, false, true. That seems to be unnecessary because if we instead optimize this code, get rid of the unnecessary if, and just do as you propose logically, else print that x is equal to y. Now, if x indeed equals y, because they're both 1 or some other value, now you're only going to ask two questions, so 2/3 as many questions, and then you're going to get your same correct result. So again, a minor detail, but again, the kinds of things you should be thinking about, not only as you write your code to be correct, but also write it to be well designed as well. All right, so why don't we go ahead and translate this into the context of an actual program here. I'll create a blank window here. And let's do something with like points on my own very first CS50 problem set. Let me go ahead and run code of points.c. That's just going to give me a new text file. And then up here, I'm going to do my usual, include cs50.h, include standardio.h, int main void. So a lot of boilerplate, so to speak, in these early programs. And now let's see. Let's ask the user how many points did they lose on their most recent CS50 P set to sort of evoke my photograph of my own very first P set last week where I lost a couple of points myself. So int points equals getInt. Then I'll ask a question in English like, how many points did you lose? Question mark space. And then once I have this answer, let's now ask some questions of it. So if points is less than 2, borrowing the syntax that we saw on the screen a moment ago, let's go ahead and print out something explanatory like, you lost fewer points than me, \n. All right, else if points greater than 2, which is, again, how many I lost, I'm going to go ahead and print out, you lost more points than me, \n. Else if, wait a minute, else seems to be sufficient logically here. I'm just going to go ahead and print out something like, you lost the same number of points as me, \n. So really just a straightforward application of that simple idea, but to like a concrete scenario here.
Yeah, you
so
could
let me go ahead and
there's
save
some
this.
gotcha in this one.
Let me go ahead and run make points, enter. No errors, that's good. Run points, and then how many points did you lose? How about it's 1 point? All right, you lost fewer points than me. How about 0 points?
Yeah.
Even better. How about 3 points? And so forth. So again, we have the ability to express in C now pretty basic idea from last week in reality, which is this notion of conditionals and asking questions. There's something subtle here, though, that's maybe not super
there's
well
one gotcha there.
designed that someone might call
If
a
you're not
magic
careful.
number. This is sort of programming speak for something I've done here. There's a bit of redundancy, unrelated to the if and the else if and the else. But is there something I typed twice, just to ask perhaps for the obvious? Exactly.
That's
I've hard-coded, so to speak, manually typed out the number 2 in 2 locations in this case that did not come from the user. So this is apparently, once I compile this, this is it. You're always comparing yourself to me in like 1996, which for better or for worse is all the program can do. But this is an example, too, of a magic number in the sense like, wait, where did that 2 come from? And why is it in 2 places? It feels like we are setting the stage for just a higher probability of screwing up down the road. Because the longer this code gets, suppose I'm comparing against 2 points elsewhere. 2, 3, 4, 5 places. Am I going to keep typing the number 2? Like, yeah, that's fine. It's correct. It's going to work. But honestly, eventually, you're going to screw up, and you're going to miss one of the 2s. You're going to change it to a 3, because maybe I did worse the next year, or 1, I did better. And you don't want these numbers to get out of sync. So what would be like a logical improvement to this design, rather than hard coding the same number sort of magically in 2 or more places? Yeah, why don't I make a variable that I can use in there? So for instance, I could create a variable like this, another integer called mine, and I'm just going to initialize it to 2. And then I'm going to change mentions of 2 to this. And mine is a pretty reasonable name for a variable insofar as it refers to exactly whose points are in question. There's a risk here, though. Minor though it is, I could accidentally change mine at some point. Maybe I forget what mine represents, and I do some addition or subtraction. So there's a way to tell the computer, don't trust me, because I'm going to screw up eventually, by making a variable constant too.
Yeah.
So a constant in a
Makes it
programming
fixed and
language, this
unchangeable.
did not exist in Scratch,
Yeah.
is just an additional hint to the computer that essentially enables you to program more defensively. If you don't trust yourself necessarily to not screw up later, or honestly in practice, if you know that number should never change, make it constant and never think about it again. This tells the compiler to make sure that even you, later in your code, cannot change the number 2. And another convention in C and other languages, when you have a constant, it's often common to just capitalize the variable. Kind of like you're yelling, but it really just visually makes it stand out. So it's kind of like a nice rule of thumb that helps you realize, oh, that must be a constant. Capitalization alone does not make it constant. The word const does, but the capitalization is just a visual reminder.
One way to think of constants is that they are a fixed set of variable, right? So a fixed set of value for a variable. So once you've initialized and created a constant, in this case, constant mine variable of a type int, so you can no longer change it on the other parts of the code, okay?
That this is somewhere, somehow, a constant. So just a minor refinement. But again, we're sort of getting better at programming just by sort of instilling these kinds of heuristics. Questions then on conditionals in C, or these constants? Yeah.
Yeah, you can also ask questions in the
Yeah,
comment
why
section.
do you not use a semicolon in like
Please,
lines
if you have
9,
any.
13? No good, like just because. Like this is the way the language was designed, and it's confusing early on. Generally speaking, when you're using conditionals, and eventually we'll see loops, there's no semicolons involved. For now, assume that semicolons usually finish your thought after a function. That's not 100% reliable of a heuristic, but it'll get you most of the way there. And just because. Left hand was not talking to right hand when some of these languages were designed. All right, so let's do something else. How about this? If I have the ability to ask something conditionally, is this thing true or is this other thing, could I write a very simple program that does something basic like tells me if a number the human types is even or odd? Well, let me just get the framework for that in place. Let me go ahead and write code of parity as a fancy way of saying even or odd. And let me go ahead and include CS50.h, include standard.io.h, int main void. Again, more on those down the road. But for now, I'm going to go ahead and get a number, n, from the user by calling getInt and asking them for whatever n is. And then Now I'm going to introduce some pseudocode. So here's the first example of a program, honestly, that I'm not really sure how to proceed. So let me just resort to some pseudocode using comments. Eventually, I'll get rid of this and write actual code. But if n is even, then print. Actually, let me just print that. Let me just go ahead and say printf, quote unquote, even, because I know how to use printf. Else, all right, I know how to printf odd. So let me just say printf, quote unquote, odd. So here, I've sort of taken a bite out of the problem, if you will. And let me go ahead and put in my little placeholders. I want to do some kind of condition. So if question marks now, let me go ahead and fill in the blanks here. Else, I'll put this here. So I think I'm OK now. I'm getting closer to solving this, but I still have this question.
So yeah, he was telling, I mean, he was discussing that, yeah, he was starting with a pseudocode. So when I do code, especially if I deal with like complex logic, I don't immediately write actual code. So what I do is like, yeah, just like the way he did with comments, although I write it out in like in plain English, like for example, if this value is equal to that value, or if this operation is something or resulted in this kind of value, then I do this and then do something else, and then yeah. So basically, it's an easier way for me to uh, polish out the logic in the code. I mean, even though I haven't written yet the actual code, so it allows me to polish and further improve the logic first. Then if everything is uh, satisfies whatever requirement for that, for example, for that function, then you start coding the actual code, or in the syntax of the language that you are working with. For in this case, if you're working with C, then you start translating your pseudocode into actual C language or C syntax. Okay.
Question mark here. How, using syntax we've seen, might I determine if n is even or odd? What do you
So
think?
you use the modulus operator.
Nice.
For
There's this
one.
little operator I mentioned by name earlier, the remainder operator, that will let you do exactly that. If you
Remainder
divide any
operator.
number by 2,
Yeah.
that mathematical heuristic is going to tell you if it's even or odd based on whether there's a remainder of 0 or 1. And that's nice because the alternative would seem to be doing something stupid like if n equals 0, or n equals if n equals 2, or n equals 4, right? Your code would be infinitely long if you had to ask all possible questions. But if I do n divided by 2 and look at the remainder, it's a little cryptic, but this will indeed do the trick. So the percent sign is the remainder operator. It does numerator divided by denominator and returns not the result of that, but rather the remainder of that.
Yeah.
So if you divide anything by 2, it's going to be a 0 or 1 remainder. And if indeed 2 divides into n evenly, giving you 0, then you're going to print even, else it's got to be odd. But there is something odd, pun intended, in this highlighted line. What is another new piece of syntax, apparently, besides the percent sign? What's a little off there? Yeah.
Double equals.
Yeah, so that's not a typo. And I even caught myself verbally saying it a moment ago just because it's so ingrained. What must this mean here?
It's an equality operator. Yeah.
Yeah, if something's equivalent to the other. So now this is the equality operator. It's not assignment from right to left. And this one, too, is an example of, like, literally
It's
humans
weird.
not really planning
Yeah.
ahead, perhaps. Left hand not talking to right hand. And that someone decided, let's use the equal sign for assignment. And then some number of minutes or days later, people are like, damn, how do we now compare for equality? Well, let's just use 2. And if you think this is a little weird, in some languages like JavaScript, there's a third version where you use 3 equal signs.
Equals, yeah.
So again, it's humans that design these languages. So if you're ever frustrated by them, confused by them, admittedly, it might just not have been the best design. But we just kind of have to live with it ever since. So let me go ahead and zoom out here. Let me go ahead and make parity here. So make parity. And again, parity is just the name of my file, parity.c. /parity, type in a number like 2. That's indeed even. 4, that's indeed even. 3, that's indeed odd. and so forth. If we continue testing, presumably we'll get the same kinds of answers. How about something else? Let me go ahead now and let me start copying and pasting some of this code, because admittedly it's getting a little tedious to keep typing out all of that boilerplate at the top. Let me create a program called agree.c that's reminiscent of like any of those forms you have to agree to online with a checkbox or typing in yes or no or the like. So let me throw away all the guts of this main program and now ask something like this. Let me go ahead and prompt user to agree to something. I'm going to go ahead and say, how about get string, do you agree, whatever the question might be. And I want the human to type y or no, y or n for yes or no respectively. So if it's only a single character, actually, I can actually get by with just get char. Not used it before, but it was on our menu of functions from the CS50 library. And if I want to get the user's response, the return value should be a char also on the left. So now we've seen strings, ints, and now chars if we only care about a single letter. And now let's go ahead, check whether user agreed. So how about if c equals quote unquote y, then let me go ahead and inside of my curly braces print out agreed or some such sentence like that. Else, if they did not type c, or you know what, let's be explicit here just so they can't type z or b or some random letter. Else if c equals quote unquote n for no, then let me go ahead and print out not agreed or something like that. And I'm just going to ignore the user if they don't cooperate and they type z or b or something that's not y or n. All right, let me go ahead now and compile this code, make agree, /agree. All right, do I agree? Yes, let's go with the default. OK, so that seems to work. No, I don't agree this time. That seems to work. How about my caps lock key is on, or I'm just really yelling, capital Y, it ignores me. Capital N, it ignores me. So obviously a bug, at least if I want to tolerate uppercase and lowercase, which is kind of reasonable. So what would be the possible solutions here, do you think?
Yeah, you can add an additional
How do I solve this and tolerate both
condition.
capital and lowercase? Maybe what's the simplest, most naive implementation? Yeah, so why not just ask two questions? Or you know what, even more simplistic, based only on what we've seen before. Let me, if you will, let me just kind of copy and paste some of this code, change this to an else, whoops, not in caps, else if, quote unquote, capital Y, and then I bet I could do the same thing with n. But here too, just like with Scratch, as soon as you start to find yourself copy pasting, you're probably doing something wrong. And what you said verbally, if I may, was actually better, because you're implying that I could just say something like or c equals capital Y, or down here c equals capital N. The catch is you can't use the word or in C. It's actually two
Pipes.
vertical bars.
Yeah.
So you can express one question or another. You only need one of the answers to be yes or true, and you use two vertical bars. By contrast, just so you've seen it, if you wanted to check if something is equal to something and something else, you could use two ampersands. This logically would make no sense here, though. Certainly, what the human typed can't both be lowercase and uppercase. That just makes no sense. So in this case, we do want or. But that allows me to tighten my code up. I don't have to start copying and pasting whole branches. I can now ask two questions at once. Questions, then, on this variation. Really good question. Can you convert the input to all lowercase? Absolutely, you could. We don't have the capability yet. It turns out that's going to require, to be easy, another library, that we could do it ourselves, knowing a little bit about ASCII or Unicode from last week. But yes, that would be an alternative, but more on that a different time. Other questions? Good question. Unfortunately, you have to be explicit in C. You can't just say this, even though that's kind of how you might think about it. You have to ask a complete question using the equality sign twice in this case. Let me ask a question now, too. It's not a typo. I deliberately used single quotes around all of my single letters here. Why might that be? Previously, we used double quotes for anything that looked like text. Yeah. Correct. String is double quotes for multiple characters, or even one technically, but yes. And single quotes for?
Single characters.
For single characters. Because my data type is different, I chose the simple route of just using a single char In fact, this program won't work with YES or NO. That's not supported at the moment. More on that another time. I had to use single quotes because that's how C does it. If you're dealing with single characters, aka chars, use single quotes. If it's a string, even if it's one single character in a string, as though you're starting to write out a longer word or sentence, that would be double quotes. And we'll see why this is before long, too. But again, just sort of things to keep in mind whenever writing code in this particular language. Yeah, down here. So short answer, if I'm understanding correctly, this would be incorrect. And this would be even more incorrect. But if you don't mind, let me kick the can a couple of weeks on this as to why this doesn't work. The most pleasant way to do this would indeed be to do something like this. But even this is a slippery slope, because what if the user does something weird, like they capitalize just the Y? You can imagine this getting messy quickly. I like your idea earlier about just forcing everything to lowercase, just to standardize things. Unfortunately, you cannot compare strings for equality like this, for, again, reasons we'll come to before long. So for today, we're keeping it simple, even though arguably it's not nearly as user-friendly to only tolerate individual letters. And there's a question over here. On a US English keyboard, it's Shift and then the / key above return. But depending on your keyboard, it will vary. All right, so let's actually now look back at something we did a little bit of last week. Let me go ahead and open a file called meow.c, because recall, that's what we had Scratch do initially. Let me include not the CS50 library this time, but just standard io.h, because I only want printf for this demo. Let me go ahead now and just print out meow. And then if I want the cat to meow 3 times like it did last week, meow, meow, meow. Save it, make meow, /meow, voila. Program is written. Correct, I claim. It ran, it compiled OK. But again, this was the beginning of our conversation last week of not being particularly well designed. And if someone wants to maybe point out the now obvious, like, why is this not well designed necessarily?
Because it's fixed with
Yeah, it's just repetition, right? Again, I literally resorted to copy paste. Like, that should be the signal that you're probably doing something wrong, or at best just lazy of you in this case. So the solution, as you might glean from last week, is probably going to be one of those things called loops. So let's just take a look at some of the syntax for loops in C. But again, no new ideas. It's just some new syntax that'll take some getting used to. In Scratch, if you wanted to meow forever with something like this, there's not a forever keyword in C, so this one's a little weird to look at, but this is the best we can do. It turns out there is a keyword called while in C, and that kind of has the right semantics, because it's like while, like do something again and again. That's the best I can do. But just like an if condition or an else if condition, those took a Boolean expression in parentheses. A while loop also takes a Boolean expression in parentheses. So I have to ask a question. Now, if I want to do something forever, I could kind of stupidly just say while 2 is greater than 1, while 3 is greater than 2, or just something completely arbitrary. But that should rub you the wrong way, because like why 2 versus 1, why 3, like just if you want true, just say true. So it turns out in C, there are special keywords, true and false, that are literally true and false respectively. I could also put the number 1 for true and the number 0 for false, but most people would just say true to be explicit. So it's a little hackish, if you will, but very conventional. There's no forever keyword in C. If I want to then print meow forever, I'm going to just use something like printf here. So again, not perfect translation from one to the other, but absolutely possible in C. What about this? This is a little more common if you want to do something a finite number of times, like repeat 3. There's a few different ways we can do this in C. Here's one I would approach. And here's where C, like a lot of text-based languages, you kind of have to whip out that toolkit of all of the basic building blocks and think about, all right, how can I build a little machine in software that does something some number of times? Well, let me give myself a variable called counter, set it equal to 0. Let me create a loop whose Boolean expression is counter less than 3. The idea being here, why don't I just kind of count 1, 2, 3? So how do I implement this physicality in code? I give myself a variable, set it to 0, 0 fingers up. Now I ask the question, is counter less than 3? If so, go ahead and print out meow. And just intuitively, even if you've never seen C code or any code before Scratch, what more do I need to do? I've left room here for one more line of logic. Yeah? We have to increase counter. So I need code like I showed earlier, like counter equals counter plus 1.
Yeah.
And so here's where like programming sometimes becomes a bit more like plumbing. Like you can't just say what you mean like you could in Scratch. You have to build a little sort of software machine that initializes a value, does something, increments it, checks it. And so it's kind of like this software-based machine, but together that's just using some familiar building blocks. But this is pretty common. Just like in Scratch, you might have used loops a bunch of times. Pretty common in C. So can we tighten this code up? This is correct, but here's some conventions that are popular. If you're going to count, just say I. A convention in programming with at least languages like C
Or
is just
even
use
shorter,
I
I
as
plus
an
plus.
integer if all its purpose is to
Increment
count
operator.
from like 0 on up. Counter's
Double
not
plus.
wrong. It's not bad. It's just like it's more verbose than you need to be. Just call it I. You don't need more semantics than that. All right, what else can I do here? There's another opportunity to tighten up this code.
I
Do you
plus
recall?
equals 1.
Yeah, that syntactic sugar that does nothing new, but it does it more succinctly. I can change this to either the intermediate format or the even tighter format of just I++. Now, this is pretty canonical. Like, this is how many people, most people, would implement something 3 times using a loop in C. Using a while loop, that is. Turns out that it's so common in C and other languages to do something finitely many times. There's a couple of ways to do it. In this model, to be clear, the logic, though, is that we start by initializing the variable, like I've highlighted here. We then ask the question, is I less than 0? If so, everything that's indented inside the curly braces gets executed, namely meow, then the update. Then the computer is going to have to recheck the condition to make sure that I hasn't gotten so big that it's greater than 3. But if not, it then does this again, and it does this again. And then it repeats, constantly checking the condition and executing what's in the block. Checking the condition and executing what's in the block. After 3 times of that, the condition is going to be false or a no answer. And that's it for the code. It just proceeds to whatever's down here, just like with Scratch. It jumps to the next blocks down below. All right, what's another way, though, to do this? Well, I've deliberately been counting from 0, and that's a programming convention, right? We started last week with all the light bulbs off, which was 0. So it's pretty reasonable to start counting at zeros, just like you would here, like no fingers are up. This is 0 fingers on your hand. But if you prefer, you could start counting at I equals 1.
Yeah.
But then you don't want to
Less
do
than
it
or
while
equals.
I is less than 3. You want to do I is less than or equal to 3. On most keyboards, there's no symbol for less than or equal to or greater than or equal to. So in C, you use 2 characters, less than and then an equal sign with no spaces in between. That just means less than or equal to. We could change it to set I to 2 and make this condition be less than or equal to 4. We could make this be 10 and less than or equal to 12. But again, just stick with the basics. Start at 0 and count on up would be the convention. Or if you prefer to count down, that's fine too. Set I to 3, and then do this so long as I is greater than 0, but you have to decrement instead of increment.
Yeah, the opposite
so again, we can do this all day long. There's like literally an infinite number of ways to
Subtract
implement
1.
this idea, and that's why I keep emphasizing convention. Call the variable I for something like this, initialize it to 0 for something like this, and just generally count up unless you really prefer to count down. Again, just certain human conventions. All right. How about another way to do this? This is what's called a for loop in C. Also very common. It's not quite as straightforward in that it doesn't really read top to bottom in exactly the same way. This kind of has a lot more logic tucked into its first line, but it does exactly the same thing. What happens here is, notice that inside the parentheses next to the word for, there's 2 semicolons, which is another weird use of syntax. They're not at the end of the line. Now they're in the middle of the parentheses, but that's what the humans chose years ago. The first thing, before the semicolons, initializes your variable. Int I equals 0. The next thing is the condition that's going to constantly get checked every cycle through this loop. And the last thing is going to be what you do after each loop, which in this case is going to be count up. So again, if I rewind, we initialize I to 0. We then ask the question, is I less than 3? If so, execute what's inside of the loop. Then the computer does this. It does the update, incrementing I by 1. And then it's not going to blindly meow again. It's going to check again the condition, is I less than 3? Then it's going to meow if so. Then it might go ahead and increment I and check the condition again. So again, this does not read quite in the same simple fashion top to bottom. You kind of read it left to right and then jump around. But again, the initialization, the constant Boolean expression being checked, and the update after each time does the exact same thing as what we saw a moment ago in this while loop format. Which one is better? They're the same. I think most people would probably eventually use a for loop once comfortable, but just because is really the answer there. All right, any questions then on loops as we've translated them to C? Yeah? For loop and while loop can both be used to do exactly the same thing. There are subtle differences with issues of scope, which we'll discuss before long, where when you create a variable in a for loop, notice that it was, again, inside of those parentheses, which technically means it's only going to exist in these 4 lines of code. By contrast, with the while loop, I declared my variable outside of the loop. That variable is going to continue to exist elsewhere in my program. So that's one of the minor differences there. Good question. But you'll see some others over time. All right, so we claim then that it's better in some form to do this with loops. So let's actually jump back to the code. Let me go ahead and now re-implement meowing with a for loop, for instance. So how about for int I gets 0, I less than 3, whoops, I less than 3, I plus plus. Then inside my curly braces, let me go ahead and print out with printf, meow, with a new line and a semicolon. So I did it pretty quickly just because I've long acquired the muscle memory. But if I now make meow, no errors there, run /meow, and I see meow, meow, meow. Well, let's do now what we did last week, which was to begin to make our own custom functions, if you will, by using our own in C. So here's where the syntax gets a little funky, but we'll explain over time what each of these keywords is doing. If I want to create a function called meow, because the authors of C did not create a function called meow decades ago, I need to give it a name, like meow. I need to specify if it takes any inputs. For now, I'm going to say no. And I'm going to explicitly say no by writing this special word void. It's also necessary when implementing a function in C, which was not necessary in Scratch, to specify what its return type is. But for now, I'm just going to say that meow is the name of the function. It takes no inputs, and that's what the void in parentheses means. And it does not return anything like like ask did, or like getString.
Simply
or
think of void as nothing.
Meow's purpose in life is just to have side effects, visual side effects by printing something on the screen. So what is meow going to do? I'm going to have it quite simply say printf quote unquote meow \n. And now, just like in Scratch, I can now just call a brand new function called meow. And here's where, too, if you really don't like the curly braces, technically speaking, you can get rid of them when there's only one line of code inside your loop. But again, stylistically, I would encourage you to preserve them to make super clear to yourself and others what it is that's going on. Let me go ahead and save this and do make meow. Whoops. Darn. All right, what did I do? Something stupid. Yeah, so 0 does not belong there. I meant to hit parenthesis. So let me rerun make meow. OK, fixed. My mistake. All right, it's still working OK. But recall what I did in Scratch, kind of out of sight, out of mind. And just to make a point, let me just kind of highlight this and move it way down in the file. Because again, like now that meow exists, it's an abstraction. I just know a meow function exists. I want to be able to use it. So let me scroll back up. My main function is the same. Let me go ahead and make meow again. And now, just by moving that function, I've created all these lines of errors.
That function.
And let's look at the first. Again, the rule of thumb here, it's a little small, but it says meow.c in bold, which is the name of the file where the bug is. 5 is the line number, and 20 is the character. So line number is enough alone. Let's see. Oh, this is what happens when I scrolled up too far. Sorry, this is the error we're now looking at. Line 7. I was looking at the old error message from earlier before I fixed the 0. Meow C, line 7. All right. Apparently, C does not know what the meow function is. Implicit declaration of function meow is invalid in C99. Well, what does that mean? Declaration of function means your creation of a function. Like I'm declaring that meow exists, but I haven't apparently defined it yet. And then C99 is the version of C from the year 1999, which we generally use here. It's one of the more recent versions. So why is that the case? Can you infer from the mere fact that I just moved meow to the bottom of the file, which was fine in Scratch, but now is bad? Why is that?
That's
Yeah,
exist
C is just
before
kind of
it.
old school. It reads your code top to bottom, and if it does not know what meow is when you first try to use it, it just freaks out and prints out these error messages. So the solution is quite simply, don't do that. Just leave it where it was. But you could imagine this getting a little annoying over time, if only because main is by name the main part of your program. And honestly, it would just be nice, honestly, if main were always at the top of your code. Because if you want to understand what a file is doing, it makes sense to just read it top to bottom. Well, there is a solution to this. You can put functions in different orders with main at the top, so long as you, and this is perhaps the only time copy-paste is appropriate, so long as you leave a little breadcrumb for the compiler at the very top of your file that literally repeats the return value, the name, and the arguments to that function, semicolon.
All right.
This is, so to speak, declaring your function. And the real fancy way is this is a prototype. It's like, what is this thing going to look like? But the semicolon means I'm not going to deal with this yet. I'm going to actually define the function or implement it down below here. This is kind of a stupid detail. More recent languages get rid of this need. You can put your functions in any order. But again, if you just think about the basics of programming languages like this one here, and as you noted, it must just be reading your code top to bottom. So annoying, yes, but explained, yes, too. So let me go ahead and make meow once more time. /meow, still working OK. And let me make one final enhancement to this meow program here. Let me go ahead now and say something like this. Let me go ahead and say, all right, wouldn't it be nice if my meow function could do something for me some number of times? So suppose I want to do this. This meow function at the moment is going to meow 3 times. But suppose I want to meow n times, where n is just some number provided by the user.
So you pass in
just like in Scratch,
the
custom functions can take inputs.
Yeah.
I just presently am saying
arguments.
void. But if I change this to int n, thereby telling the compiler, hey, meow still doesn't return something, but it does take something as input. It takes an integer, and I want to call it n. So this is another way of declaring a variable, but a way of declaring a variable that gets handed into as input the function.
Or parameters.
So now if I tighten up main here, now I can actually do something really cool, just like in Scratch, which is this. If I now look at this code, let me zoom in here. Now my main program is really well written in the sense that it just says what it does, meow 3 times. This works, though, because I define meow is now taking an input, an integer called n, and then using n in my now familiar for loop. There's one change. You might have caught my one mistake. I also have to remind myself up here to make that change too. Again, this is one of the only redundancies or copy-paste that's sort of reasonable. But there I have now a better version. So let me go ahead and rerun this. Make meow, /meow, voila. So again, no change in correctness. But now, again, we're sort of modularizing our code. And heck, what you could do now, and this is just a tease or a feature down the road, those header files we talked about early, those libraries, this is the kind of modularization we're talking about. We, the staff, wrote a function called getString, getInt, and so forth. We put it in a file called CS50.c, and we put little breadcrumbs, specifically these things called prototypes, in CS50.h. So that when you all, as aspiring programmers, include CS50.h, you are sort of secretly telling the compiler at the very top of your code what the menu of available functions is. Why? Because in CS50.h is lines like these. Obviously not for meow, but for getString, getInt, and so forth. And in standardIO.h is the same lines of code for things like printf. So that's all that's going on there. It's just a way of telling the computer in advance what functions to expect. Are any questions then on these here? Correct. So if you don't mind, I want to continue to wave my hand at that detail for today. Indeed, int main void is a little weird because, like, what would the input to main be? We have no mechanism for providing input yet. And what does it mean for main to return anything? Like, who is it returning to? For another day, if we may. They're going to come into play, but that for now today is just something you should take at face value as necessary copy-paste to begin programs. So meow is a function that takes an input, the number of times to meow, but it didn't actually have a return value, hence the void. But what if we actually want to create our own function that not only takes 0 or more inputs as arguments, but also returns some value, maybe an int, maybe a float, maybe something else altogether? Well, it turns out in C, we can do that as well. Let me go ahead and create a new file here called discount. And let's implement a quick program via which we can discount some regular price by some percentage, as though there's a sale going on in a store. Let me go ahead and include our usual CS50.h, followed by standard IO at the top. Let me give myself int main void, as before. And inside of main, let's go ahead and do something simple. Let's give ourselves a float called regular, representing like the regular price of something in a store. Let's go ahead and get a float from the user, asking them what that regular price is. Then next, let's go ahead and declare a second variable, also a float, called sale, ultimately representing the sale price after some percentage discount off. And let's go ahead and simply calculate whatever regular is and say 15% off is a pretty good discount. So let's go ahead and discount regular, whatever it is, by 15%, which is equivalent, of course, to multiplying it with the asterisk by 0.85. Of course, if we're taking off 15%, we multiply the regular price by 0.85. Now let's go ahead and print out the results here. Let me go ahead and say printf, sale price, colon. Let me go ahead and use %f, but more specifically %.2f, because at least in US currency, we typically show cents to 2 decimal places, followed by a new line. And then let me go ahead and plug in the value of sale. All right, let's go down here and do make discount. Enter. So far, so good. /discount. And the regular price is maybe $100. So the sale price should be $85. So our arithmetic seems to be correct here. But let's fast forward now in time. Suppose that we find ourselves discounting a lot of prices in an application, maybe a website like Amazon where they're offering some kind of percentage discount. And it'd be nice to have a reusable function that just does this arithmetic for us, simple though it may be. So let's go ahead and modify discount this time to give ourselves our own function called discount, for instance, that takes an input, like the regular price that you want to discount, and then it also returns a value. It doesn't just print it out. It returns a value, namely a float that represents what the sale price is. So let me go down below main and go ahead and define a function that's going to return a float, because we're dealing with dollar amount still. The function is going to be called discount, and it's going to take one input, like the price that we want to discount. In here, I'm going to do something very simple. I'm going to say float sale equals whatever that price is times 0.85. And then I'm going to go ahead and return sale. Now, for that matter, I can actually tighten this up a bit. If I'm only declaring a variable to store a value that I'm
Just
then returning with this keyword return, I actually don't even need that variable. So I can delete the second line. And I can actually just go ahead and get rid of that variable altogether and immediately return whatever the arithmetic result is of taking the price input, the argument that's being passed in, times 0.85. So a very simple function that simply does the discounting for me. As always, let me go ahead and copy paste almost the only time it's OK to copy paste the prototype of that function to the top of the file so that when compiling this code, main has already seen the word discount before. And now let me go into the code here. And instead of doing the math myself in main, let me presume that we have some function already in our toolkit called discount that lets me discount the regular price and return that value. And then down here, my code doesn't need to change. I'm still going to print out sale, the variable in which I'm storing that result. But notice what I've done here. I've sort of abstracted away the notion of taking a discount by creating my own function that takes a float called price or anything else as input. It does a little bit of math, simple though it is here, and then it returns a value. But notice that discount is not printing that value. It's literally using this other keyword called return so that I can hand back that value, just like getString hands back a value, just like getInt hands back an integer without printing it for you, so that I, up here on line 9, can go ahead and store that value in a variable if I want, and then actually print it out. Let me go ahead now and recompile this code with make discount. Let me go ahead and do /discount. And let's, again, do $100. Sale price is going to be $85 as well. Now, it turns out that functions don't have to take just 0 or 1 argument as input. They can actually take 2 or 3 or more. So in fact, suppose we wanted to now enhance this version of my program and take in as input to the discount function, not just the price that I want to discount, but also the percentage off, thereby allowing us to support not just 15% off, but any number of percentage points off. Well, let me go up here and declare an int say and call it percent off. And let me ask the user for how many percentage points they want to take off. So I'm going to say percent off inside of the prompt here, get that int called percent off. And now, in addition to passing in regular as an input to the discount function, I'm also going to pass in percent off. But I need to tell the computer that it is taking now 2 arguments. And the way I do this is just with a comma down here in the function's own definition. Here is going to be a percentage argument, a second argument per the comma. And I'm now going to use that percentage in a slightly familiar way. I don't want to just do percentage like this, because, of course, that's going to increase the size of the total price. I actually need to do a little bit of real world math where if this is a percentage off, like the number 15 for 15 percentage points, I need to do like 100 minus that many percentage points, thereby giving me 100 minus 15, 85. And then I need to divide that by 100 in order now to give myself 0.85 times the price that was passed in. But if I go ahead now and save this, run, make discount one last time, I notice that I've actually got an error here. What have I done wrong? Well, I need to change that prototype too. And again, this is admittedly an annoying aspect of C that you have to maintain consistency here, but that's fine. I'm just going to go up here, change this to int percentage, spelling int correctly. And now let me retry compilation, make discount, crossing my fingers this time. Worked OK. /discount, and voila, $100 and percent off, say 15 points, and voila, $85. Now, it's worth noting that I've deliberately returned the results of my math from this function. I haven't just done the math on the original variable that's being passed in. In fact, if we take a look at this second version, where discount is now taking a price argument and a percentage argument, notice that I'm not doing something like this. I'm not just saying price equals price times 100 minus percentage divided by 100 and leaving it at that. The problem there is that this variable price is going to be scoped to that discount function. And we'll encounter this again before long, but this notion of scope just refers to where in which a variable actually lives or exists or is accessible. So it turns out if I change price in the context of this discount function, that's not going to have a lasting effect. If I actually want to get the result back to the function that used the discount function, namely main, I actually do need to take this approach of actually returning the value explicitly so that ultimately I'm handing back the discounted price. All right, well, let's go ahead and maybe, how about let's just use these primitives in just a few different ways. How about a little game of yesteryear, Super Mario Brothers. And in the original Super Mario Brothers, and in bunches of variants in, so you have like these side-scrolling worlds that look like this, where there's some coins in the sky hidden behind these question marks. So let's just use this as a visual to consider how in C could I start to make something semi-graphical, like not actual colors or fanciness. That feels like too much too soon. Just something like printing out some question marks. Well, if I go back over here, let me create that actual file that I alluded to earlier. So let me code up mario.c. Let me go ahead and include standard io.h, int main void, again, which we'll continue to copy paste for today. And then let me just go ahead and do something simple like 1, 2, 3, 4, and a new line. All right, this is what we might call ASCII art, which just means graphics, but really just implemented with your keyboard. And if I make Mario and do /Mario, it's not nearly as engaging visually as this, but it's the beginning of this kind of map for a game. Well, if I wanted to now print out of those things dynamically, let me go back to my code here. And instead of printing out 4 all at once, I could do something like for int I gets 0, I less than 4, I plus plus. And then inside here, I could just print out one of them at a time. Let me save that, make Mario. And at the risk of disappointing, so close, but I made a mistake. Just stupid aesthetic. The prompt is not on the new line. How could I move it?
/n.
Yeah, I need an escape character, the \n, but should I put it here?
No, after the for.
OK, no, because that's going to put it after everyone, and it's going to make this thing vertical instead of horizontal. So logically, just like in Scratch, put it at the end of the loop. So something out here, and just print out, for instance, only quote unquote new line. And now if I do make Mario again, /Mario, OK, we're back in business. But a little better designed in that now I'm not repeating myself multiple times. I'm doing this again and again. But let's do one other thing here with Mario. Let me go ahead and ask the user how many question marks or coins to print. The catch here is that there's another type of loop that's helpful for this, and it's called a do-while loop generally. A do-while loop is similar to a while loop, but it checks the condition last instead of first. Recall earlier on the slide, we had while, open parenthesis, close parenthesis, and I kept claiming that we checked whether I is less than whatever it was, 3 in advance, again and again. A do-while loop just inverts the logic so that you can actually do something like this. At the top of this program, I'm going to go ahead now and give myself a variable n, like this, of type integer. And then I'm going to do literally the following with the keyword do. N equals get int. And I'm going to ask the user for the width, like the number of $signs to print. And I'm going to do this while n is less than, say, 1. So this is a little cryptic. But the salient differences are the Boolean expression is now at the bottom of my block of code, not at the top. Now, why is this? Well, the difference here, if I make Mario, is, I need to add CS50.h because I'm now using getInt. If I now compile this version of Mario and do /Mario, a do-while loop is helpful when you want to do something no matter what first and then check some condition or some Boolean expression to see if maybe, in this case, the user cooperated. It would make no sense if the user typed in, say, 0, because like there's no work to be done. It'd be really weird if they said -100, because that makes no sense logically. So with this simple construct here, I am doing the following while n is less than 1. The implication is that as soon as n equals 1 or is bigger than 1, I'm going to break out of this loop, and I've got myself a variable called n containing essentially a positive value, 1 through 2 billion or so. And I can now use this, for instance, here. Change the 4 to an n. So now my program is completely dynamic. Let me go ahead and do make Mario, /Mario again, and I'll do 4. Still works. I'll do 40. Still works. And the difference here with the do while is if something like this involves getting user input, well, there's no question to ask. Like the user hasn't given you anything yet, so you have to do something first, then check and break out of the loop if the human has, for instance, cooperated in this case. All right, well, why don't we escalate to something more like this in the same game, where your underground is Mario, and this is like a 2-dimensional wall that's popping up here. It looks like a 3x3, for instance, for the sake of discussion. And it's like made of bricks, so I'll use maybe hash symbols this time. Well, it turns out that we can nest, that is, combine some of these same ideas as follows. Let me go ahead now and change back to this code. And I'm going to keep the do while loop from before. And I'm going to ask, though, this question, what's the size of this square? I'm going to assume it's like n by n, so 3 by 3, 4 by 4, whatever. So I'm just going to ask for the size of this square of bricks. And now, how do I do this? Well, I'm going to go ahead, for instance, and print out, how about for int I gets 0, I less than n, I plus plus. Let me just keep it simple and print out something like this. Just a single hash symbol, that is a brick, and a new line after it. All right, let's make Mario, run Mario of 3. OK, that's close to being it. I've got a column. All right, but I need it to be wider. So the solution last time was to get rid of the new line and then maybe put the new line here, out after the loop. All right, so let's do make Mario, /Mario, and type in 3, and All right, so I kind of need to combine these two ideas somehow. So how might we solve this problem? I want to print like rows and columns, not row or column. How do I do this? Yeah, add another loop in the for loop, right? If you use one loop conceptually to kind of count the rows from top to bottom, and then within each row, you then sort of typewriter style, old school typewriter, do like character, 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 character horizontally, I think we could do exactly what we want to achieve here. So how about this? Let me get rid of this line and get rid of this line for now. And let me just give myself another loop on the inside. And since I'm already using I, another reasonable convention here would be to say something like j. So j also gets 0. J is less than n. J plus plus. And now, what's going to happen? Let me go ahead and print out just one of these things at a time. And let me save and write. Let me run this. Let me see how close we are. Make Mario 3. OK, 3. That's clearly wrong, but I see 9 things there on the screen. So we're close. What's the
You
one
forgot
fix I need now to sort of move the old school
return line
typewriter head down to the next row when appropriate?
after the inner
What do you
for
think?
loop.
Yeah, I need one of these \n and probably, let me add some comments now to help everyone visualize what I've done. For each row, for each column, how about print a brick, just to kind of explain the logic. And so I add that because now, move to next row, I could do something like this with a \n. So here's where the comments, really my pseudocode, actually kind of illuminates the situation a bit. Let me go ahead and recompile Mario, /Mario 3. Now we're talking. It's not a perfect square just because these hash symbols are a little taller than they are wide, but that's just a font detail here. Now I've done something that's quite more akin to something like this. All right, so let me pause here and see if there are any questions. Again, the code's getting a little more complicated, but we're just building like more complicated programs like in Scratch with like familiar puzzle pieces, some variables, some loops, some conditionals. It's all the same as before. Yeah? Can you multiply strings in C? No. But ask that same question again in a few weeks when we get to Python, and the answer will be yes. Other questions? Yeah? In C, you must specify the return type, the name of the function, and the inputs or arguments to the function in that order. And if none of them are applicable, you write the word void. So same question as earlier. Let me kick that can a week or so, and we'll come back to that, and we'll see why. But for now, just take on faith that you need to do that with main, because main is a little special, similar to the when green flag is clicked. It, too, was a little special as well. Yeah? Yes, if you want to get out of a loop early, you could do this. So let me answer this question this way. An alternative to a do-while loop would be to do something like this. How about while true? So do the following forever. Let me go ahead and get an int from the user for the size of this thing. If n is greater than 0, that is a positive integer, then go ahead and use a new keyword called break. This is identical to what we just did. It's just a little longer. It's like a couple extra lines. A lot of them are blank. And so it's just an alternative. But a do while does the same thing, but a little tighter, if that's an answer to your question. All right, so let's now introduce, finally, a sequence of problems that I've kind of been brushing under the rug, though we did see a little bit of evidence of this earlier when we tried to add 2 billion and 2 billion, and it overflowed the number of bits in an int, so to speak. Let me go ahead and code up a program called calculator again, but I'm going to go ahead now and change us to floats. So I'm going to change x to a float, and I'm going to use getFloat. And a float, again, is just a floating point value, which is a fancy way of saying a real number with a decimal point in it. And down here, I'm going to go ahead and use %f for float. And I'm going to go ahead now and do one more thing. Instead of addition, I want to do something fancier like division. So divide x by y. And I'm going to give myself another third float called z, as we did at the beginning of today. And I'm going to print out z instead of x and y explicitly. So I'm going to go ahead now and do make calculator, /calculator. And let's do something like, 2/3. 2 divided by 3 is 0.66667. So that's what you would rather expect. Let me run it again. 1/10. All right, so 0.1 and a bunch of zeros. That, too, is what you would rather expect. But now let me get a little curious. It turns out that in C, you can modify the behavior of these format codes a little bit. By default, you get like 6 or so digits. Suppose that you want to get exactly 2 digits. You can more succinctly say 0.2 before the f and after the %. This is the kind of thing that's hard to remember, but you Google it and you find that, OK, format code for floats uses 0.2 to do 2 decimal points. So let me do make calculator again. /calculator, how about 2/3, 0.67. So it handles the display of significant digits for us here. And now let me go ahead and do 1/10 and 0.10. So it's adhering to that. Well, maybe I really want a lot of precision, right? I've got a really powerful computer. Let me see 50 numbers after the decimal point. That's a lot of significant digits. Let me remake the calculator. Whoops, typo. Let me remake the calculator. /, not Mario, calculator. And how about 2/3 again? Well, that's
That,
interesting.
it's not enough.
Pretty sure it's supposed to be like a 0.6 with like a line over it, right? In grade school math. All right, well, maybe that's just a bug. How about 1/10? OK, that's really getting funky. So what's going on? It seems that my program can not only not do addition very well, we eventually hit problems in the billions, we can't even do very precise numbers here. What's going on?
It exceeded its
Exactly. In a nutshell, the
limits.
computer's approximating the answer using that many numbers after the decimal point. But the problem fundamentally is actually very similar to that integer overflow from before. And I'm using that
Exceeded
now
its
as a term
limits.
of art. Integers can overflow if you're trying to use more bits than you actually have available to you. You sort of change them all to ones, and then you're out of bits, so to speak. Same thing here, but in the different context of floats. If you only have 32 bits, or heck, if we change to double and only have 64 bits, that's a lot of precision, but it's not infinite. And yet, pretty sure there's an infinite number of real numbers in the world, which is to say a computer with finite memory cannot possibly represent all possible numbers in the world because, again, there's not an infinite number of permutations of 32 or 64 bits. It might be a lot, in the billions or more, but it's still finite. And so, indeed, this is the computer's closest approximation to what's actually going on there. And so this is an example of what we would actually generally call floating point imprecision. Floating point imprecision refers to the inability for computers fundamentally to represent all possible real numbers 100% precisely, at least by default in languages like C. Thankfully, in the world of scientific computing and so forth, there are solutions to this problem that just give you more digits, but the problem fundamentally is still going to be there. So there's a reason I changed x and y to floats. Let's see what would happen if we rewound a bit, and instead of using floats for x and y, again use, say, integers. So int x and int y, and let's go far back and use getInt as well, thereby giving us integers x and y. Let's still leave z as a float, because at the end of the day, we want to be able to handle fractions or floating point values. But let's go ahead now and print out this value of z, having changed x and y now to ints. Make calculator, /calculator, and let's do, say, 2 for the numerator, 3 for the denominator, and voila, it's not 0.666, and it's not even rounding oddly. It's just all zeros this time. So why is that? Well, it turns out that C, when dividing an integer by an integer, is always going to give you back
Zero.
an integer, an int.
It only
The problem
deals with
is
whole
that
numbers.
floating point values don't fit in ints. Only the integral part to the left of the decimal point does. Everything at and beyond the decimal point itself gets thrown away, known as a feature in C called truncation. When dividing an integer by an integer, you get back an integer. But if you're trying to then store what's actually a floating point result in that integer, C is just going to throw away everything at and beyond the decimal point, leaving us with this case in just the 0 from what should have been 0.666666, and so forth. So let's see one more example, in fact. Let me go back to my terminal here. Let me do /calculator again, and let's do 4/3. This time it should be 1.33333, and so forth. But let's see. 4 divided by 3, both as integers, this time gives us 1.0000, but there too. The answer should be 1.333, but the floating point part is getting truncated or thrown away, leaving us with just 1. So how do we solve this? Well, certainly, we could just use floats from the get-go as I did. But if by nature of your program you only have access to integers or maybe even longs, for which the same problem would occur, what we can actually do is called type conversion. And we can explicitly tell the computer that we actually want to treat this int as though it's a floating point value. And we can do that for both x and y. So let me go back to my code here. And I have a couple of options, in fact. I can convert y to a float by doing this. I can cast y
Casting.
to a float by
Yeah.
literally writing the type float inside of parentheses right before the y. And if I really want to be explicit, I can also do the same to x. But strictly speaking, it suffices to just change one or the other, not necessarily both. Let me go ahead now and do make calculator again, /calculator, and let's try 2 divided by 3. And now we're back to an answer that's closer to correct, but indeed we're still having some rounding issues there. Let's run it one more time for 4 divided by 3. There too, we're closer to the right answer at least, but we still have that floating point imprecision, but that's going to be another problem altogether to solve. And here in a little more detail is that issue of integer overflow, which is in the context of ints. Suppose that we think back.
Okay, so yeah, we've got a little over an hour of session or lecture for this time around. And so yeah, that was quite a lot of points and or topics have been discussed. And so yeah, just a quick review or summary of what has been discussed for this past hour. He started with conditions. So with conditions, when you are dealing with something that is like asking for a question that would result in the answer would be either true or false, then uh, there's uh, there's a construct in C that is called if statement, or if there is uh, if your conditions would be more than one condition, then you would deal with if else or if else if or statements. Okay, so I don't know if I could uh, let's see if we could uh, navigate back to that uh, yeah, this one. So yeah, this is one way of dealing with conditions. Okay, so you have the if statement or the if else statement. And so what the if statement accepts is a conditional statement. In this case, you are comparing values. Okay, if the value are the same, in this case, if the C variable is equal to the Y character, then yeah, they are considered true, and then it would execute whatever uh, code or statements is within this curly braces. And again, if you have multiple different kinds of conditions, then you can chain them together to form an else if, or you can also have just an else, sort of like a default. If none of the conditions uh, are satisfied, then you can put else at the bottom of it. Okay, and so
type
we have also he has also discussed yeah, the equality operator. In this case, the in C, equality means double equal symbols, okay, or double equal signs. So yeah, part of that also is you can combine multiple conditional expressions. So that means that if next for this one is, let's go through the example of, I don't know if we can grab that. Let's see. Uh, let's see if we can get to that slide. Yeah. So yeah. Uh, hopefully, let's just bear me. Okay, this one. So this one, uh, if condition, he in pseudocode he indicated or, but in C syntax, the operator for the or condition would be this double vertical line or double pipe. Okay, so that would mean that you can chain together different conditions if you want either one of the conditions to be true, then you can use the or. Another thing as a uh, another type of this kind of conditional operator would be the and, double ampersand sign, wherein if you want to combine different conditional statements that would have to be true, all of them would have to be true, then you chain them together using the double ampersand, okay, or the and operator. Okay, and so next to that is the for loop. So he has discussed the different looping statements that you can use, which means looping statements are statements wherein you can execute code repeatedly. So if we go back to that point where he discussed the for loop, yeah, here. So if you can see the syntax for the for loop, no, I think, anyways, let's just continue. So with the for loop, for loop is one way of doing repetitions or executing the same set of code repeatedly. So you have the for loop, you have three different parts, okay, to remember. So the first one, these parts are separated by this semicolon, okay? So the first part, prior to this first semicolon, is your initialization part, that is where you initialize your variables or whatever uh, data that you require within your for loop. Okay, and then the next to that is this condition section. Okay, so this condition section is, it accepts a condition expression wherein it would return, it should either only return true or false. So if it, in this case, you have I less than to 3, if I has been 0 in this part, then this would evaluate to true, which means that it would execute. Okay, so you have to remember that in the condition part, so long as it's true, then it would execute whatever is within this for loop. And then after that, you have this I plus plus, or the incrementation operation that is done there here after the second semicolon. This would be your, we can think of this as the post execution, which means that after this section of code here inside here executes, then this section gets executed. Okay, uh, usually you do incrementation here. Okay, but you can also add other uh, logic here. Okay, and so one type of loop also that has been discussed is the while loop. Okay, so with the while loop, let's see if I can go back to that uh, slide here or section. Okay, here. So here he discussed about while loop. So with while loop, it's also another form of doing repetitions. But in this case, it's much simpler than the for loop. So what the while statement or for loop needs is just a condition. Okay. So long as the condition within this parenthesis is true, which in this case counter is less than to 3, then it would execute what is inside here. So what the difference with the for loop is that your initialization code is outside. Okay, so in this case you have initialized before the while statement. Okay, so he has set the counter here is equal to 0. That would be the equivalent to the initialization part of the for loop. And then also, for you to have control of your while loop, usually with incrementation, so you have to put the incrementation at the bottom prior to ending your while loop. Okay, so that you can have breaking control of your while loop. So if you don't put this, it could go on into an infinite loop, which means that, yeah, it would just keep on executing repeatedly, non-stop, right? And so yeah, and another one, yeah, for loop. And then yeah, function prototypes has also been discussed, which means that in C, for you to place your let's go back to that portion where the function prototype has been discussed. All right, hopefully can get back to that. Not sure. That is 3. Oh, okay, sorry, it's 3 5. Okay, just bear with me, please. Okay, so now here he discussed that he has separated function meow. So for C to recognize your functions outside of the main or after the main function, you will have to declare the function prototype or the signature of your method. Okay, so in his example, he placed the meow function after the main int. I mean, sorry, after the main function. So for that, for C# to recognize that one, you will have to put it before the main function. Okay, just declare the signature or the function name and then the parameters and then return type, then you'll be all good. The C would recognize that. Okay, and then the do while loop has also been discussed. So with do while, it's another form of looping or another form of looping statement. Okay, so here with do while, it's almost much like the same with while and for loop. You can still do repetitions with it, but the difference is that there's a slight difference in wherein with do, you can execute code at least once, okay? uh, with the other ones, there's a higher uh, tendency that your code would never get executed, okay? But in the duals what in the dual statement, you are assured that you could get, or your code gets executed at least once, okay, prior to get, or prior to breaking down, depending on what is the condition on the while loop. Because you notice the condition is at the bottom, and then the execution of the code is on the top, which means that after the do, it executes the code here, and then after that is the evaluation of the condition, if whether it would still continue with the execution of the body of the loop, okay? So there. And then another thing is, with loops, you can also nest loops, wherein, which means that you can put loops within loops, okay? Now, the depth, or the how deep you can go, it depends on what you want, or it depends on the logic that you are trying to build or to do. You see here, he has two for loops. So one for loop on the outside, and then another for loop on the inside, to print out this sort of like bricks, okay? Let's pretend that these hash symbols are bricks, okay? So you can create 3 by 3 bricks, but the number of bricks are variable enough, or it could vary depending on the input, okay? And so you have also mentioned format code, and then the floating point imprecision, wherein if you're dealing with numbers, and then there's tendency that the number that you are, I mean the expressions that you're trying to do would be greater than the data type that you're working with, okay? And so yeah, that could get messy. So you have to be careful with that, especially when you're dealing with uh, decimal numbers, okay? And so I think that would be the end of this session for this one. So we have spent another hour of Harvard CS50 Computer Science course, another hour of lecture, and hopefully you'll join me again on another hour of another lecture. That would be our hour 5. Okay, hopefully uh, you'll still be with me and join me on this one. And this would be quite a long journey. We're not even halfway uh, with the course. Okay, and so yeah, just keep learning, and see you soon, and see you again in our next session. So yeah, thank you everyone, and yeah, have a great day. Thank you.